Hello everyone, I'm Nilanjana Ghosh from Azanbin Cares International School. Today's lesson is on ionic product of water which has a symbol Kw. Chapter 8, Quantitative Equilibria. The learning objectives for today's lessons are 8.1b, write the dissociation reaction of water. C. Write the expression of Kw, then work out the units. D. State that the only factor that affects the value of Kw is temperature. Water shows both acidic and basic property. In aqueous solution, a small fraction of the water molecules undergo acid-base reaction with each other to produce the following equilibrium. One water molecule donates a proton to the other water molecule. The water molecule which donates the proton is acting as an acid, and the other water molecule which accepts the proton is acting as a base. They form H3O+, which is called the hydroxonium ion plus OH- ion. The above reaction is called autoionization of water. We can simplify this equation by writing H plus instead of H3O+. So the equation is simplified as H2O liquid gives H plus ions plus OH minus ions. The equilibrium expression for this reaction can be written as Kc is equal to the concentration of the products divided by the concentration of the reactants. So H plus ion concentration times OH minus ion concentration divided by the concentration of water. Now, the concentration of water is a constant because it is present in large amount. So, we can incorporate the concentration of water into the Kc. So, when Kc is constant, concentration of water is constant. When two constants multiply with each other, we get another constant which is Kw, which is equal to the product of H plus ion times the OH minus ion concentration. The new constant Kw is called the ionic product of water. Let's calculate the unit. H plus concentration of H plus ion has a unit of moles per decimeter cube, and concentration of OH minus also has a unit of moles per decimeter cube. When we combine them together, the unit is mole to the power 2 dm to the power minus 6. So Kw, which is ionic product of water, is equal to concentration of H plus ion times concentration of OH minus ion, which has a fixed value 1.0 in 10 to the power minus 14 at 25 degrees. pKw, the word P stands for, or the letter P stands for inverse log of, is equal to pH plus pOH equal to 14 at 25 degrees. Some important points about Kw. Kw is equal to concentration of H plus ions times concentration of OH minus ions. The value is constant at a given temperature. Its value is equal to 1.0 into 10 to the power minus 14 at 25 degrees. Kw value shows that in acidic solution, there will be some OH minus ions present, and in alkaline solution, there will be some H plus ions present. Kw has a name ionic product of water. Factors that affect ionic product Kw. Ionic product of water is only affected by changes in temperature. The value of Kw increases with the increase in temperature. So let's look at this equation. For formula, we know that Kw increases with increase in temperature, which means both the H plus ion concentration and OH minus ion concentration increases when temperature is increased, which shows that the equilibrium shifts to the right when temperature is increased, suggesting that the dissociation of water is endothermic. When an acid or a base is added to water, Kw remains constant, but the concentration of H plus ions and OH minus ions do not remain equal. When an acid is added, the concentration of H plus ion increases, whereas the concentration of OH minus ion decreases. So, in an acidic solution, concentration of H plus ion is greater than the concentration of OH minus ions. Similarly, when a base is added, the concentration of the OH minus ion increases, while the H plus ion concentration decreases. So, in an alkaline solution, the OH minus ion concentration is greater than the H plus ion concentration. Let's do some questions. Question number 1. When temperature rises, does the pH of water change? To explain this question, I've provided you with a set of data. Let's look into it. Here we have temperature, Kw and pH. Now when we see when the temperature is increasing, the Kw, the value of Kw is increasing and the pH is decreasing. Now why is that? Before we start answering it, let's look into the formula of pH, which is pH is equal to minus log 10 H plus ions. So pH and H plus ions are inversely proportional to each other. When H plus ion increases, pH decreases and vice versa. So we know that when temperature increases, Kw also increases. So both H plus ion concentration and OH minus ion increases. When H plus ion concentration increases, from the formula we know the pH will become less. So that's what we see in the table. However, water is still neutral because with change in temperature or increase in temperature, the concentration of both H plus ions and OH minus ions has increased in the same amount, keeping them both equal. So water is neutral. Question number 2. Calculate the pH of pure water at 25 degrees. In pure water, we know concentration of H plus ion is equal to the concentration of OH minus ions. And we also know Kw is equal to concentration of H plus ions times the concentration of OH minus ion, which has a value fixed at 25 degrees, which is equal to 1 into 10 to the power minus 14. Substituting OH minus as H plus because their concentration is similar, we can write H plus ions concentration times H plus ion concentration is equal to 1 into 10 to the power minus 14, or H plus ion concentration square is equal to 1 into 10 to the power minus 14. If you want to find the concentration of H plus ion, which is square root of 1 into 10 to the power minus 14, which gives a value of 1 into 10 to the power minus 7. Using the formula, pH is equal to minus log of H plus ions. Substituting the value of H plus ions, we get the value of water. pH is equal to 7 at 25 degrees. Thank you. I hope you have enjoyed today's lesson. Bye. Have a nice day and stay safe.